Hey guys, my name is Samantha, and today we're going to be going over maximum depth of a binary tree. It is one of the 75 questions in the Blind 75 collection. So basically, this question wants to know what is the maximum number of nodes along the tree's longest path, where the path is defined by the root to any of the leaf nodes. And a leaf node just means that it does not have any children. So in this case, the answer is 3. The path that could have given this answer it could be two things. It could be the 3, the 20, the 15, or the 3, the 20, and the 7. So we just want to know what the maximum depth at any point of the tree was. And so with all tree questions, we always say, if not root, then we have to return. Just standard. And the way that C++ works is that if you just put these braces, it is smart enough to know what the return type is meant to be. And so with tree questions, this is just how I do it. You guys can do it however you like, but I like to make helper functions. I just think it's cleaner a little bit. And this helper function is going to take in a tree node, and it's also going to take in a depth. And so we're going to start off by just calling this helper function, and we're going to send in the root. And when we are at our root, our depth is 1, and we can confidently assume that because we know that the longest length in this first example is 3. So it's inclusive of the root. So we're going to send in a 1, which indicates that when we are at the root, we have a maximum depth of 1. So this helper function is going to do all the work, and we're going to have a global variable. And by the end of this helper function, it's going to go through, it's going to traverse, it's going to set the answer to whatever is the maximum depth. And then by the end, we can just return ants. And so again, with anything in trees, we're going to say if not root, then just return. And the first thing that we're going to do is we want to traverse all the way down until we get to a leaf node. And only if we are at a leaf node can we, compare our current answer to our current depth, and that way we can, do some math. And so I guess I'm gonna put in, just so we can see, if not root left and not root right, which means that we are at a leaf node, then we're going to say the answer is equal to the max of any answer that we have previously seen and our depth. And so that's going to take care of setting this equal to whatever is the max. And then what we're going to do is a depth first search. It doesn't matter which order we traverse because we just want to get to the leaf nodes. So we're going to call this function recursively on roots left and right. And the order doesn't matter. It can be on root right or left. So we're going to call it on left. However, the thing is that we're going to send in depth plus 1. Because if we are starting at 3, which has a depth of 1, when we are at 20, that has a depth of 2. So we're going to send in depth plus 1. And we're going to do the same for the right. And that is the full solution for this question. The complexity is O of n, where n is the number of nodes in the tree. And just to quickly go over kind of what's going on, tree questions can be really confusing, especially with the recursive calls. So we start at 3, and we're calling this helper function with our root parameter being the 3, and our depth is 1. The root is not null, so we're going to get to this line of code on line 18, and we're going to call the function on the left and send in a depth plus 1. So now our root is 9, and our depth is 2. And so our root is not null. We're going to call to the left. In this case, our left is null. So we're going to return. And now we're going to execute this line of code, which is where we're going to call 9's right. We can see that also gets returned because it's null. And at this point, we know that roots left and right are null. So we're going to say our answer is equal to the max of our current answer, which is 0, and our current depth, which is 2. So ants is going to get updated to 2, and then recursively it's going to get returned back to the 3. We already executed this line of code for the 3, so now we're going to execute this line of code for the 3, and it's going to continue this process until it gets to the third depth of 3, and this overrides it, which is, you know, the trick of this question. But that is how you solve it. Let's hit submit. I can't. And that is how you solve this question. Thanks for watching.